Hello, everybody, and welcome to episode 2 of Random Destruction. This time, I'm going to do something that I did 3 or 4 years ago in Tyflow. So, this time it's going to be in Houdini, and hopefully, it's going to be a little bit better as well. So, this is what we are going to be creating. Yeah, so let's get started with it. We want to start with an empty EU, and I'm going to assume that you know a little bit about Houdini. A tiny bit. Okay, so here we have a empty SOP Yeo node, and we're gonna start with laying down a grid. This is the one that we're gonna draw on. We probably don't really need to have a grid, but I'm gonna have a grid anyways. So with a draw curve, we can draw a curve. Let's set this to geometry, and having this cursor here at the viewport, press enter, and now you can draw. And this is probably like, you want to make this look nicer than this probably, but for this tutorial, I think it's fine. So we got lots of points here, and we might not need to do a resample, but just to show you if you didn't know about it, resample, what this does is it's even out the points generated on in this case this spline. We can lower it if we want to. Then it does a bunch of other things like curve view, which gives you a value of let's see, curve view. It starts with 0 and goes all the way to 1. It's super useful a lot of times, but not in this case. But I just wanted to show you. If you don't have this geometry spreadsheet somewhere, I think you should. So it's in the inspector geometry spreadsheet. This way we can see attributes that points, vertices, and primitives have. It's very useful. Now, what we want to do, we want to have some sort of collision going, following this this spline that we have here. One way is use a what's it called, carve, and tick the extract. Now you can see. Not sure if you can see, so where do you do it? Make it bigger, and now we can see we have our point that we can animate. So let's do that with Alt click. I didn't want to do there. Let's do it in the first frame. And then let's have it like that at frame 40 something. And then I want to ramp up the speed. Maybe not something like that. And here we go. Okay, that's really fast. So maybe, let's see. Goes really fast. Whatever. Let's keep it like that. Let's copy a collider onto this. So we have the points, which we have 1, and then we want to have some form of collision hue. Let's see. Polygon maybe. I'm just gonna squash it. Make it smaller. And now we have something that we can use to collide the pieces on. Well, a collision hue. Let's create a floor. I'm gonna use a bound and just pipe in the grid. This is gonna make the, you know, whatever size this one have, the bound is gonna have, and then we can just add a little bit of thickness, some padding to make it a little bit bigger. And we do need to make sure that it is standing flat on the grid here. So we can use a center and set the justify Y to minimum. So now it's perfectly placed in our environment. What else? What do we need to do now? Like we need to, I'm gonna use RBD material fracture. I'm also going to use my own points for this, which it's not necessary, but to use that we need to check this input point. I'm just going to turn on the details so we don't have like straight cuts. What this does as well is gives us high res proxy, which is low res, and then constraints. We're not going to use the constraints in this case, but it gives you that if you want to have it. Now create the points that we are going to fracture with. ISO offset. This is so that I can scatter points inside a volume. Otherwise it would just be I can show you. Let's do this. Now it's like inside, and if we remove this, it's going to be on the surface. Let's see, 500 points. That's decent. And just for the fun of it, let's add some more points on certain places. So adding a attribute wrangler, running it on points, it loops through all the points in this case. So what we want to do is what do we want to do? We want to remove some points here. So if I do an if statement, and we can use a rand function. Rand gives you a value between 0 and 1 based on a seed, and the seed is going to be our PT num. So for each point, it's going to give us a unique number. And let's say if it's bigger than 0.3, then remove point. And I believe it's a yield. Yeah, so most function has this geometry handle, which is basically going to be the inputs 0, 1, 2, 3. What we also can do is, if we want to, do a ch and then call it something, whatever you want. Click on this little icon here, and now we can control it like this. And let's see what else. Okay, so point replica, like to use that one. It's going to generate a bunch of points. let's give it like, I don't know, 12 maybe. Let's go with 10. Let's do a sphere, make it smaller. We can add some noise. And now we just want to merge these two. Now we have it all. Some of these, as you can see, go outside of the EO. They aren't really going to be doing anything for us. We could use a raise up. I'm not going to do so in this video. You can see my previous video where I used the raise up, I think. So bring these into the last input and let it cook for a bit. And sometimes things can take a lot longer to fracture based on size of your object. You can store the initial size with like a rest. So store it and then you can shrink it. And then you can do your fracturing, and then you can add another rest further down, and as you say, like extract this way, and then it becomes the original size again. That's a way of making it faster, but in this case it was pretty fast. And what do we want to do now? So what is this going to give us? It's bringing in a null, high res, and low res. We can see this is the high res, this is the low res. We're gonna sim on the low res, and they are gonna drive the high res later down in our little system here. They also give us constraints. We're not gonna use it, but they are there. You want to use it, unless you want to do it yourself. It also gives us name, like that. And that's really important because the RBD solver needs to have a name attribute, and it's going to treat every unique name value as a separate thing. And also because we want to drive the high res with the low res, they need to be the same. Okay, they need to have the same name and also at the same place. Otherwise it's going to look wonky. What we also want to do is I want to make this into a point or a pact. I'm not going to create name attributes because we already have name attributes. And if I did, then I would have to fix that on this side as well, because then they wouldn't have the same name attribute values. So now we just pack this. And now we can do some simulation. Let's see, what do we want to do with dot network? Before that, let's just create a null, say out call. I'm just gonna copy, Control C that, and let's just do this. Just call this out, notice. Like always, we need a packed object and pick the out low res, rigid body solver. We need a gravity. We want to have a merge and a ground plane. Let's see, make sure that these are in the correct order. So ground plane first, then everything else, or put it at mutual. Whatever you prefer. And let's not see the ground plane. And here we go. We have our ground. What we also need to do is bring in the collision object. I'll bring it like this. I'm gonna paste in our collision, and we now have it. And if I run it, nothing is gonna happen because we need to click the use deform geometry, and now it does something. It follows the animation, and that wasn't so funny. Let's see if we can make it a little bit bigger, maybe. I mean, it's something. Maybe we can lower this. Oh yeah, so now it's gonna have to refracture this again. Let it cook. Yeah, it's fine. Not amazing, but let's see. Let's leave it like that for now. And let's move on. We now have this simulated. Let's add a DOP import and just drag in our network into the DOP network field. And now we have it here. I don't want to have everything. I want to just have the RBD packed object 1, which is our ground. What I'm gonna do is we're gonna have to change this a little bit. Let's do 600 maybe, 650, add more, and let it cook again. Let's pretend I'm fast forwarding. And let's see if we get some better result now. Yeah. Let's keep it like that. I'm just going to show you how to do the how to drive the high res. So object merge, drag this in here into the object. Now we don't have to have lines going everywhere. You don't need to do that, but there's a transform pieces. With this, takes the points, and then we have the high res, and now we should have, now we have high res stuff going on here, instead of seeing the ugly low res stuff. Cool. And of course you want to play with this. It's not very optimized either. Right now everything is active, which you could set everything to inactive in the solver, so it just stays flat. It's still gonna be, it can be collided with, but, and then you can make, let's see, this, anything that is close to this to be active. This way it's not all active, but we're gonna keep it like this in this video. What else do we need to do? I think we need to do the secondary. As in these small pieces. And these are also an RBD, simulation. So let's start with the debris source. Not there. Over here. So what the debris source does is, if anything gets further apart based on the distance, it's going to create particles. So if we, as you can see, it kind of lights up. So first we can remove anything that isn't active and remove at life end. We also want to set a threshold, so, because I don't want to have these guys here. We can do a volume threshold as well, so it kind of removes all the tiny stuff. And there we go. And because this is going to be in a simulation, I don't want to have this many. So let's go to the density scale, do a lot less, and that's, I think, good enough. So the idea here now is that I want to scatter kind of a debris object onto each of these. So how do we do that? First, we want to set this to a frame duration, because I only want these to live at frame, 1 frame. Otherwise it's going to be 1 second, I think. And maybe we can actually turn this up a little bit now. Keep it like that. We also want to have variation. We don't just want to have one piece. So there, if you do a, what is it, attribute adjust integer, it's even going to have a variant attribute, which I think is just it's not a known thing, but I guess it's what you would use. Set it to random. We're going to adjust this later. But let's now create the debris. So I'm going to go with a box. We're going to add some subdivisions to this. And we are going to do a mountain, which I always struggle with. But just something like that, maybe. And I probably want to make this smaller as well. Okay, that's fine. So now we want to fracture this into a bunch of pieces. Like always, I'm using the ISO offset. Set it to 100, so it's more accurate. Add a scatter. And this is how many we want to use, or how many pieces we want in our simulation, how many variations. Now we can do a RBD material fracture again. I'm going to remove the secondary layer, turn on the input points, add interior detail and edge detail, and let's see. And here we have 10 pieces. Like that. One thing we want to do to make this more procedural is copy this and put it in here. Paste relative reference and just -1. So we change the number here. It's going to change here as well. 20. Here it's 21, but -1. So that's fine. We don't need exploded view. But we're going to want to give these guys a variant, attribute. So how do we do that in a more procedural way? We can use a for each loop. For each, and it's going to be a named primitive because they are named. We have name here. I'm going to bring in the high res on this one. Not very optimized, but it's fine. In here, we want to pack. And we can, by the way, just look at this. We can do one at a time. We want to give them a unique name, right? They have to be, or the variant is going to be 0 to however many we have. So to do that easily, we can create meta import node. This one have iteration. So it's a, for each iteration in the loop, it's going to be 0, 1, 2, 3, etc. So now we can just add a wrangle. I'm going to take the fourth one in here, like so. And now we can basically say I for integer. What's it called? Variant. And then detail. First one is the input node, which is 3 in this case, as you can see here. The other one is the name of what we want to bring in, which is the iteration. Second one, you can just do a 0. And let's see, I forgot our comma. And now they have, okay, here we go. We have all the different IDs. So with that, what else do we need to do? Let's see. Let's first, I'm gonna bring this down here. We can do copy to point first. Let's see how this works. So we have the points, which is this one. And then the geometry. We also need to specify variant. Variant. Is that how you spell it? Variant. Copy. Variant. There we go. Just want to make sure I spell it correctly. And now we have this. Doesn't look much right now. Let's remove the color. We don't need it. Now, we want to bring this into the RBD solver. One problem though, and that is name. So we need to do something with that. So they all have to have a unique name. So we can do that afterwards here with a wrangle again. This is again on points because we are, packed EOS. So we can say name. Do we need to do, I don't know. I don't think we have to do S first because name is like a known thing, maybe. Sprint F. What this does is we can say, let's say debris underscore percentage sign S for integer string. Let's do another one, percentage sign S for string. And now in that order, we can say ptnum will be the first S. And then we can do frame, which is going to ensure that these are unique. So we probably going to adjust some stuff in here later, but for now, that'll do. So what do we need to do more? This is our object, yeah. It's in a dot network. And I'm all over the place. Out debris. Oh, I want to have big ones. Like so. And whatever. I'm just going to bring it in here. There is one thing we have to do, by the way. So we're bringing in the packed object, right? Before, let's merge ground, yes. Shift R to flip the order. Now the problem here is we only want this to like follow the current animation, like that happened during the first RBD simulation. Right now, it's affected by gravity, right? So we can, let's just reverse the gravity. It floats up. So let's see, use object transform. Let's just first see. Yeah. So we want to go like so, and then we want to say again, wrangle. It's a popular thing. And then we want to say, these are the two ones that we want to use. I at, and this is also an I at. So we want them to not be active, and we want them to be animated because they are. So that's a 1. 1 for yes, 0 for no. If we try this now, ta-da, it's not affected by gravity, which we had had a reverse gravity here. But let's bring that back again because we want our debris to actually have gravity. But now they're just going to follow. And I do believe you have to have this override thingy checked, right? Let's see. Oh, maybe you don't. Learn something new every day. Let's see. Huh, I guess you don't have to have that checked. So let's not. But in that case, we probably don't need this as well. Okay. Let's bring in our debris. We need a subsolver for this. And we bring it in either in post or in pre-solve. I'm going to bring it in the post. I'm going to copy this, go in here. All we need to do is an object merge, paste it in, do a merge it into the previous frame, and we have some things, okay? Let's see, do we have too few? We probably want to have more velocity, but I'm gonna just raise this up a little bit. Definitely have a lot of debris now. Let's do 25 and let's fix this here. What we want to have is, let's say we have the incoming velocity and then we do times equal, let's add more, like 0.5 to what it already have. And we can also use p-scale to randomize the size of it, which is p-scale. If we just set this to a static value here, just to see, and if we want to really, like, if it's messy, we can always use a blast, and also to be able to remove the original ground, which we need to do anyways. We can say, let's say, give it a ground group. And let's see, ground. And now we don't have the ground because we blasted that away. So this is our debris only. So if I change this to 1.5, it's going to be really big. So what we want to do here is we can do maybe a fit 0, 1. This is how you can remap a value between 0 and 1 to something else. So it start off with yeah, let's just try rand ptnum do 0.5 to 1. Yeah, so some of these are really small, otherwise aren't, but they're still too big. 0.6 to 5. I guess they are big in the beginning. I wonder if we do in the pre-solve. Let's see. Okay, that's better. So nice. But let's see, what else can we do? So maybe the velocity is too much. Let's keep it like that. What I also did was I layered this. I didn't really layer it, but I made another one, which are smaller. I'm going to copy this. And then in this one, I'm going to say 1, 2, 3. Going to set these guys to have a little bit more velocity. And we can play with the mass. So we say mass. This is like 1. But we need to set the mass here as well. Otherwise it's going to be, I don't know if it's going to work otherwise. And these guys are going to be, because these are bigger, we can say they are 5. So these are going to push the smaller ones because they are more mass. And of course you could use the P scale to really give some variation to the mass. Now we're just setting a static value, but you know, let's do it like this for now. Going to the subsolver, I'm just going to, whoops, copy. It's Alt, click, drag, paste in our other one. And now we should have even more. We have smaller stuff and bigger. I guess it looks all right. You have to play with the animation on this and whatever else, but do have some issues. I don't care. Oh yeah, we do have issues because we need to actually say these can be small. We have to change the name, otherwise I guess it didn't work, but now it should work perfectly fine. So keep that in mind. Needs to have unique name, value. Yeah. I mean, if we were to set this to have like, well, at least in the first one, and we said that all of these pieces had the same name, then the solver will basically treat it all as one object. Let's now go ahead and merge, or let's see. Object merge. Let's just do this. We have the high res with the low res. Now driving. It's all fine. And then we merge also in our debris that we created. So we split out the original ground stuff. And now we have both of them. It's slower, but we have both of them. That's okay. Now I believe we have some, if you want to have like velocity, not sure if there is V on this. Oh, there are. So I suppose that you have that. Otherwise, like there's a trails up. If you want to have, if you don't have velocity, so we can just compute velocity. But anyways, what else can we do? Yes, another thing which I forgot. They don't have spin. If we look here, there is no spin, which is the W. So let's, I'm gonna do this. V, because it's a vector, W equal, I'm just gonna take the velocity times 10 maybe. And do the same thing here. No. It's like spinning a little bit more. Looks better. But when you do this, and if you want to follow along, like you want to like really make this even more random, like the mass. You know, you don't need to have this set as 1 for everything. You could use the p scale value that you have, and kind of do the same thing like the fit 01, and then the p scale, and then you remap that, or but yeah, that is everything. And to go even further would be to have maybe a third layer of just particles. They can have like dumb collision detection. You can have a lot of them, and then I guess like a smoke simulation on top of that as well. Yeah, that's all for this video. See you in the next one.